Yeah, I'll share the screen right now. This moment. So should I start right now? Okay, good morning, everyone. I'm Jakub, and today we'll spend at least 2 sessions talking about geocomputation, talking about geocomputation with R, talking about reproducibility, just a tiny bit, and talking about spatial data analysis. So my plan for today is to spend maybe half of our time on a lecture, and then another half will be spent on some exercises. So I would like for you to try something and to test different things. So let's start with chapter 1, geocomputation. So let's start with some brief overview and to put some context to the things I will show you later. I really like this description of what we are doing, because here this is based on the David O'Sullivan talk from Geocomputation 2019, that we have tons of different names, and no new names are popping up. So you can combine that. Oh, we have geospatial computing, for example, and so on. But as for our workshop and our lecture today, I'm of course focusing on geocomputation, but the main point here is that there are many things called differently, but the core ideas stay very similar, or stay almost the same. And geocomputation was defined by Stan Openshaw, and the main idea is that we have various types of geodata, and we want to build geotools to provide some ways to do scientific analysis and to answer some scientific questions. And at the time, at 2000, when he made that statement, it was hard to think about reproducibility the same way. So if you go back in time, there's 20-something years, the whole idea of having some code examples and being able to run them somewhere else were not exactly there in terms of hardware, software, data access, and so on. We are probably still not there yet, but definitely there is a much clearer path, and I will try to show you some subjective approach to this path. And one of the first things that you probably can think of when it comes to reproducibility is talking about GUI versus computer languages, programming languages. So here there is a table from the Geocomputation with R book, where we can just compare those two approaches. But most importantly, for the sake of this lecture, look at the last row. We are trying to move from repeating ourselves and minimal reproducibility to potentially maximal reproducibility, however we will define that. And then we can use those tools, we can use those skills in many different fields. So for me, that's very attractive. I am definitely not a specialist in any of those fields. I try to be a generalist, but many people need those skills to be able to do their work and answer their questions. And then maybe it's obvious to most of you, maybe not for all of you. We need to firstly define how we store our data or how we represent the real world. Because, we can look around ourselves in this building and we see the floor, we see the tables, we see the glasses, I can see you. But how to define that in space? And what kind of detail we want to have? What kind of representation is the best for us? Because it's not only about being the most detailed, but it's the most important to find the best representation to solve our problem. And sometimes the simplest representation is the best. And traditionally, when we think about data in GIS, we think about two main data models. So vector data model, when we use points, lines, and polygons, and raster data model when we think about representing surfaces. And with vector data model, basically, we think about two main parts of this model. So we think about geometries, so locations in space, and we think about data, so attributes. And you can see here that our locations are connected to attributes. And currently, this vector data model, the most prominent way of dealing with this data model is just to treat points as the main building block. So lines are basically points connected by straight lines. And polygons, the same, those are just points connected by the straight lines with the idea that the first and the last point is the same. With raster data model is that we are filling the whole space, the whole area that we are working on with values. And in the basic model, with the grid model, each cell has the same size, and each cell has at least one set of values. And that kind of values you can represent by a map, for example. This idea is good for large data because compared to vector data model, we do not need to store all of the coordinates. So try to even imagine that on this very simple example. So in this example, if I want to store this data as polygons, I would need to have 5 points for each cell. So I have 20 cells, so I would need 100 values. I would need to store 100 values just to store geometries. But with raster data model, we are only storing what are the coordinates here, and what's the number of rows, of columns and rows, and what's the size of rows and columns. So we are storing 6 values compared to 100. But let's try to imagine that we don't have 20 cells, but we have 20 million cells. Then I need to store 1 million values as polygons, but I only need to store 6 values in rasters. When it comes just to geometry, I'm not talking about values yet. And then plus as many values as we have. So that's why this raster model is often used. That's one of the reasons. There is another few reasons, but that's one of the reasons why we often use the raster data model. And then currently we are trying to think about spatial data in other contexts. So you already heard about it, and you will hear that in the coming days about the idea of spatial data cubes or spatial data arrays, or however you will call them. So now we don't think about just one polygon or set of polygons. We don't think about one raster or just set of rasters. We think about multi-dimensional objects, spatial objects. So in this case, you can see that we have our, let's say, raster in this example. But this raster goes through time and goes through many attributes and can go through many bands and so on and so on. So we store several bands at the same time. At least in the raster realm, it has some limitations, of course, because we need to have consistent dimensions. But this also allows us to do a lot of calculations or computations in real time. But the spatial data cubes, I assume that most of the time when you think about this term, you will see examples of rasters, but it could be also polygons or vector data. So our geometry stays the same through time or through bands, but it's connected to values for different years and for different land cover categories and so on and so on. So that's probably things that will still be developed, improved, and expand in the coming years. We also can think about spatial data as point clouds. So you have LiDAR data, so you have a laser going from, for example, drone or plane and coming back to the drone, and we know what's where it bounced back. And this is fairly often used in some fields, much often than the other. So here you can see those are basically trees here. So LiDAR data is very often used in forestry, but on the other hand, it's very often used in archaeological studies. So there are a lot of archaeological sites discovered in for example, Amazonia, due to use of the LiDAR data. So we can see what's below the tree cover, what's underground, and discover some structures that we were unable to see otherwise. And then when we think about spatial data, we shouldn't forget about coordinate reference systems. So that's the way how we relate our locations to space. Well, this is important because, for example, I can say that this corner of my screen has some coordinates. So I can say, oh, those are coordinates 10 by 10. And this is 0 by 10. And this is minus 10 by 0, or something like this. But then if I want to take a picture of that and want to send that to somebody else, and they want to reproduce that, it will be very hard for them because they don't know how to locate the same coordinates in space. And the other example, you just get some old map and you don't know what's the CRS. And you want to put that map, compare that with like current maps. This is a hard task, but that's why it's very important to not only be aware of the coordinate reference system, but also actively try to keep them in your data and work on them. And then when we think about CRSs, we often think about two types of coordinates. We think about geographic coordinates, so usually they are in degrees, and we think about projected coordinates, so they're usually in meters. Not only meters, but some metric distance. And using one or the other could give us different results. And sometimes the decision which one we will use in our project is crucial. The one tip I can give you here is kind of obvious, but it took me some years to discover that. If you do one analysis, it doesn't mean that we need to use one CRS for the whole analysis. You can switch CRS to your analysis and use proper CRS for each step. You can do calculation on one and create a map on the other. It's not. I think most often it's not important to keep that consistent. It's more important to get proper results. All right, so we have our spatial data. We know how it's stored. We know a little bit about CRS. So let's think about data sources. Because usually we don't want to just have the data on our computer. We want to be able to get the data from somebody else. And we also want to be able to save the data and share the data with somebody else. That's the goal, I hope. And there is a long history that you can read here. But the main story is that there were, through time, through this relatively short time that we are working with spatial data on computers, there were different approaches. So there were some approaches of like software databases. So each software had its own database, and then you need to know how to put your data on this database, and only work with this database if you want to do any analysis. And then next step was to work with file formats. So people invented some file formats, and some software was able to use some file formats, some were able to use other. Sometimes you can read some file formats, but you cannot write them, and so on and so on. So that's the idea I still remember very clear. So and that was of course a problem, because if you want to do your analysis in more than one software, that could be hideous. Sometimes you need to find some middle file formats to just move from one to the other, and that was not always easy or straightforward. But finally, we moved to the time that we are right now, that we have software like Goodall, which allows us to work with read and write hundreds of spatial data formats. And here I'm just showing you some selected spatial file formats. And those file formats, they are not equal. And probably you know one difference between them. The main difference is that some are used often, some are used less. Some are more popular, some are less popular. But also, they have different models, so they have different licensing. So some file formats are open, some are partial open, some are not very open. So it's hard to read them or write them. Some file formats are better, like GeoJSON, to work with smaller data online. But some are better to work with larger data set. And some file formats, you need to read an entire data set to on your computer. And for some data formats, you can just take a part of the data set. So you can see we have a lot of them. And currently, for my projects, usually my starting point is very simple. When I work with raster data, I usually work with geotiffs. And we can discuss about that a little bit later. But when I work with vector data, I usually start with GeoPackage. I'm not saying that I'm using both of them always, but that's, I think, a good starting point in 2022. So that's the idea that we have currently. So we have those several dozens, maybe hundreds of different file formats, and all of this software basically use the same idea. So we are going through Goodall and reading the data in a consistent way. And this idea allows us to, for example, work in R, save data in Goodall, and put the data in Python, or maybe do some analysis in ArcGIS and go back to R. I don't know why, but maybe that's your thing. And then this field, similarly to data models, is not stale. There are still many new developments, and there's always something new to learn. So, for example, there's a huge, I think, rise in using something which is called STAC, so Spatial Temporal Asset Catalog. So that's basically a description format that stores metadata about geospatial data sets. So you have some information, and this way you can find them on cloud platforms and easily subset them before even trying to download them. So you can find data sets that you're interested without going to some GUI or before downloading hundreds of files. Another, I think, very nice development that you will hear a lot this week is about cloud-optimized geotiffs. So those are geotiffs that they can be hosted on websites, but you can also have them on your own hard drive. And then you don't need to read the whole file. You can read the file just in tiny parts, and that's fairly efficient. And then we have some new kits on the block, like GeoPackage, GeoArrow, ZAR, and so on. So I think there will be a lecture about that tomorrow afternoon. But just to let you know, the basic idea here is that or maybe two basic ideas for GeoArrow at least, is that we want to have a unified way for different programming languages, but we don't want to even put data in our memory. We want to work in the file, calling from programming languages. And the idea of ZAR is how to store those spatial temporal data cubes and how to do that efficiently. So basically, you can think about ZAR like a cloud-optimized GeoTIFF, but for data cubes. As always, I added some links. So if you are interested in some topics, you can click on the link and read a little bit more. And next, let's say we've got our data sets. We know about what they represent. We can do a lot of analysis already. So we have those basic vector operations like intersect or some spatial joins or buffers. We can do raster processing, so we can do some basic raster processing, so map algebra. So those are very, very well established ideas that are available, I would guess, in most GIS software, including programming languages that support GIS operations. And we can work with interactions between them. So we can rasterize, we can extract the data, we can vectorize, and so on. But then that's probably not our result. We want to do something more. So we want to do some analysis. And here I try to gather some ideas on how we can classify different spatial data analysis. And here you have that we can classify them based on input data type. So we will work probably differently with network data, differently with point patterns, and differently when we have multi-layer raster data. But we can also classify spatial data operations using what's our goal. Do we want to do some interpolation? Or maybe we want to do some simulation. And again, our approach and our tools will be slightly different. And then we are not only talking about analysis. So of course, data analysis, data processing, data transformation, so the things I quickly showed you are important. But currently, when we stay with programming languages, we can do few more things. So we can work on software development. So that's basic idea of the open source software, that you start as somebody who never type a line of code. Next, you are typing your code on daily basis. Next, you are maybe adding new issues on GitHub. And next, you are developing your own software. Because that's the progression that I think many people who are lecturers here done in the past. Because it's fairly easy, because you're using the same tool. The same tool is used to write scripts, to write functions or packages or develop new methods. And finally, we can think about, when we think about geocomputation, we also think about visualization. So we think about how to represent spatial data visually. And those examples are, of course, the visualizations to show to other people. But we also think about visualization as a part of our workflow. So probably 99% of the cases when I read new data, the first thing I do, I visualize the data. That's the step for me to understand the data better. When I do some analysis, then I again visualize the data to check if my intuition is good on what I've done or not, and so on and so on. If I do reprojection, again visualize data to see if I've done that correctly. So that was the basic context of geocomputation. But now let's maybe move to the smaller niche of geocomputation with R. And then you need to think about two approaches. So on the left, you can see that we have very nice lawn with just very short grass. It looks very nice, but it's very simple. So nothing is going on here except that it's very well organized. And on the right, we have see that we have different flowers, different grasses, and they are different sizes. We have some hilly area and so on. And this is how I think about GIS software versus using GIS in programming languages, especially R, because that's the thing I know the most. So when we think about, for example, let's stay with open source software. Let's stay with QGIS. So if you want to use QGIS, there is only one way to read the data. If you want to open your vector, there is only one data model to read that vector. If you open your raster, that's the same. If you want to do an operation, usually there is one preferable way to do that. With R, we don't have that. You can read your geo package using 5 different packages. And then if you want to work on them, there could be possibly 10 different paths to get the same results. Is that confusing? Is that complex? Definitely. Is that a problem? Often. Is that good? Yes. And I know that it's contradictory, and I know that it's not always the easiest way, but because of that, you can decide on what path you are choosing. But also, people who are developing new ideas, they can work in this complex ecosystem and compete and look at each other and get ideas from each other. And this way, development happens quicker. And this way, you are getting, in general, better results. Similarly, like biodiversity here versus biodiversity here. So in R, currently, we have a few hundreds packages that are more or less directly related to spatial data. Here, I'm putting just a short summary, just showing you different groups of ideas. But again, as I mentioned before, there are more than one way to, for example, do static visualization in R. There is more than one way to connect R to GIS, other GIS software. There is more than one way to read spatial data in R. And that could be complex at first. And it could be problematic later, but it also gives you this power. It also gives you this this opportunity to use things which are always improved and always better. So if you want to learn a little bit more, so if you have 4 minutes to spare, there is a website called Spatial Grand Task View, and there is an introduction on this website, I think like 4 paragraphs. And basically those 4 paragraphs are half of my talk today. So if you don't want to listen to me, you can just go there and read those 4 paragraphs. So I showed you this slide before, but I never mentioned that we also have the time dimension, not only in spatial data, but also in software development time. So you know the grass will grow, the flowers will bloom, and so on and so on. And the same with software. So software is used by some people, and some software is going to be used more. Some software will be used less. So there are some trends and fashion in software as well. And here I'm showing you a visualization of some basic R spatial packages and the number of downloads through time. You can see the downloads are on the logarithmic scale. And you can see that I think 2 main trends. One trend that you can see is basically growing number of downloads in total. So there is still that trend of more and more downloads. And then you can see that some packages like SP has slower growth comparing to packages like SF. And I will explain that a little bit in a few minutes, but let's go to code for the first time. Let's go to our code for the first time. And here you see that we've got, we start our very tiny script with attaching 2 packages, package called SP and SF. So the SF package is the base R package that I use to work with spatial vector data. And in this package called spdata, I store one of spatial object called world. So this is a multi-polygon data with countries on a global scale. And for each country, I have several other attributes like population or name or life expectancy and so on. So this is how data is stored in SF. Our data is basically a data frame, so a spreadsheet. And there is one column that we cannot see here that stores geometries. So there is one column that stores the information about locations. And the summary of locations that we can see at the top of when you type the name of your object. And then, as I promised to you before, I usually start with plotting my data. So I can just use the base R plot function, and I will get some quick visualization. And this allows me to make sense of my data. Is this data, maybe, do I have broken geometries? Is my data, do I have missing values? So you look here, for example, I don't have life expectancy in France and Norway. Do my data make sense? Are those relationships valid or not? So how this SF package works? So the package, and you will see that always, packages do not live in a vacuum. So SF package is actually built on top of several C or C++ libraries. And I mentioned Google already. So every time you read your data to SF, so you have your packet, your file, your geo package, your shape file, you read that to R, it will go through Google. And then if you want to save your file, it will also go to Google. And this way, you can be quite sure that you can open this data set in QGIS later, or in Python, or in GraphJS, or whatever else. When we do reprojections, we will go to Proch library and so on. So SF is not developing the code to do everything. It just gives you this consistent wrapper to work on your problems, but using very well-established tools. But also, SF next is used by other packages. So next, another people can build on top of it. So you can see that it's basically not one package, but we are starting with many libraries. We are using SF, which has a lot of connections, and then a lot of more people are building on top of that. So we can just like reverse pyramids, more or less. The package I use for working with raster data is called Terra. So Terra package allows us to read, process, and write raster data. And I think it's fairly well taught and it's well written. So if you have raster data, you are not reading that into your memory, but you are just getting a pointer to the data. And if you want to process your data and your data is larger than your memory, it will be processed in chunks and using temporary files on your hard drive. So that's the way it works. And that's the way it allows you to work with fairly large rasters. So if you type, so here I have a data set called asrtm.tif. If I just type the name of the data set, I will get a quick summary of my data set. I will know about its dimensions, resolution, extent, the CRS, and some summary statistics are here as well. Again, I start with plotting. I need to look at my data to see, oh, do I have missing values? Is my data is located in the place I expect? Are those relationships, those elevation values make sense? What are the units here? So those are the questions I ask myself when I do that. And if you look at how Terra package is made, the main idea is very similar. So we have those libraries like Google Geos NCDF. I assume Proch and some more as well. And then there is a C++ library written by the Terra author, which connects them. And then when we run some code from R, it goes to this library and calls those different external libraries. So now let's look at the bingo card. So that's the card I often think when I do analysis and I see other people doing spatial analysis in R, because we need to think about several different concepts, and I'm showing them to you because I think they are useful, especially when you start. So in R, you have R Spatial. So you can have a website called rspatial.org, but you also have a website called r-spatial.org. So this one is related to packages like Terra. This one is related to packages like SF. So that's also this like ecosystem thing that we have very similar names. And what's important to highlight here, there is no like war between the two groups and anything else. There is huge and a lot of collaboration. If you look at the GitHub issues and discussions, and what's important, maybe I would also go here, is that you can convert between different classes in R. So because of this collaboration. Another thing which is very important is legacy. So different developers have different ideas. So do you want your code to be able to run your code in 5 years? Or do you want to make some breaking changes because you think that the new version will be much better? So that's very hard question, and it takes some time to from the developer point of view to decide, but it also from the user point of view. I've been using some ideas, but now should I stay with my old approaches or should I move to new approaches? Where is the threshold that when there is a crossing point? When should I decide to do that? And again, I'm just showing you those as questions. We can discuss them because I think there are many, like all of you could have different problems, different questions about them. So I'll be here for the whole week and we can discuss them later. But I'm just highlighting to you that those are the things that are should be always in your mind. And then I showed you the SF, I showed you Terra, but in R we have also different packages and different approaches. So we have a stars package, which main idea is to work with those spatial temporal arrays. We have S2 package, which is used by SF. So this is for spherical geometry. So we don't treat our planet as flat surface. We try to treat that as sphere and do spherical calculations. Next, we have packages like LiDAR. So LiDAR is a great package. I really recommend you to use that package if you work with point clouds, because that's the role on how to read, process, and work on LiDAR data, even very large LiDAR data. There are packages like SF networks that build upon some ideas. So the idea of the SF package and the digraph package to not only think about lines as dots connected by straight lines, but also to think about what's the relationship between those lines. Can I go from here to there using only this line, or should I go somewhere else because maybe there is no connection between this point and this point? So we can do some routing and other ways of working with network data. We can think about packages like Spatstat, which is used for example, point pattern analysis. So we want to analyze point patterns. And again, this package has a different way to read its data and write this data, but we can convert from SF to it fairly nicely. And there is something which I for the sake of this talk named hypertidyverse. So there is a person called Michael Sumner. He lives in Australia and he works often with data from South Pole. So then you need to discover and build your own tools on how to read large data efficiently, how to work with different projections and so on. And he has a lot of ideas on how to do that. So I think that's also nice to see maybe less popular work, but get some new ideas and get some new inspiration. And just to close my lecture, before I will give you some exercises, the last story. So R, as I showed you before, we have those building blocks, we have those packages that are used by many people, but then, so we have those huge packages, and then we have some tiny developers like myself who try to use those larger packages. And maybe we are not always suited to do that. So I will give you an example of a package that I worked on for the last year or so, called Supercell. So the basic idea here is that this is, I have raster data, so this data in the background, and then I want to create some polygons which borders are related to similar, in this case, colors, but that could be similar to values of their neighbors. So what I'm doing here, I'm reading the R logo. So that's the old R logo. Maybe I should do like a pull request to change that to a new logo. Doesn't matter. Then I'm creating those supercells. I try to make them around 500 of them. And then they are created. So those red lines are the supercells, are the polygons with more or less consistent colors. So you can see that, oh, this is like dark. So this supercell causes this darker color and so on. And on the right, you see the same supercells, but now I'm not using the original color. The colors here are the averages here. So you can see that basically that's like a compression. It could be think about as a compression algorithm, but basically it's about generalization of it. Because it's not only for image data, it's also for spatial time series data or spatial patterns or categorical data. So you can work and generalize your information. But I'm not going to talk about the package. I want to just give you some ideas. And the idea is that in this package, as you can see, I'm using the SF. I'm using the Terra packages, so the packages you've seen before. But I also use a package called Philanthropy for some calculations. And I use a package called Future Apply if some users want to parallelize their calculation. I also use CPP11 for the C++ code I wrote for this package. So only those 1, 2, 3, 4, 5 packages are used by the software. So it seems that, oh, it's not a lot. It's 5 packages. So if there is some change here or here, I can react very quickly because I don't have 20 dependencies or 50 dependencies. So my idea is here. Oh, I have just like a tiny network of dependencies. And if something changes, I just need to fix one hole and I will be fine. But in truth, it's more like this. So actual network is all over the place and it's much, much larger than I thought. And I can show you here. So this orange dot here is my package. And then you can see, oh, it connects to this package and it connects to this package. So it connects to Future Apply and it connects to Philanthropy and it connects to SF here. But then Philanthropy connects to this one and SF connects to this one and Future Apply connects to those one and so on and so on. So at the end, you can see that, oh, I thought that I have 5 dependencies, but in fact, I've got probably like around, I don't know, 100 of them. And long story short is here that I wanted to tell you, there may be 2 stories. The first story is that even when you are creating your own package, you're not developing something which is totally isolated from the rest, for bad and for good. And I think it's good to be aware of that when you're starting. That this is the case. This is how the software development happens. It's not you alone working on something. It's a lot of people working, and that's why when you take something from the community, it's also good to give it back because you are somewhere here as well. And just to close this, one example of spatial visualizations. So in R, we have a few dozen, I believe, packages for making different spatial visualizations. The one I use is called TMap. And here you can see that basically I read my data as RGB. So this is this background raster. Next, I added my supercells and colored them to red. So that's in the foreground. Next, I added north arrow and put it in the right top corner, and added map title and removed the map frame. So this is fairly consistent way to build maps using R. What's great with tmap is you can also, if you just change the tmap mode, so one line of code, you can also see that map as in the interactive mode. So you can move around, pan, zoom in, zoom out, and click on the map. I think tomorrow we will also hear a lot about another great package called MapView. So I recommend you to go to the MapView lecture. All right, so that's all for what I wanted to say for the first part. So again, I will talk a lot after the lunch, but for now, I prepared you exercises using 3 different difficulty levels. So I put a link to my slides to the Mattermost. So I hope that that you have them. If not, the website is the slides are very easy to find. So just go to my website /OGH 2022, and on slide number 49 you will find 3 links. So you can maybe I can go quickly to the Medium one. So if I just open this, we'll get hopefully, yeah, we'll get some exercises. So here you see that there are 10 exercises, but I encourage you to, with our limited time, to finish at least the first 8. So basically, they ask you different questions and step by step push you to try different ideas and get some results. So you can download this file, and if you want, you can open that in. You can create your own RStudio project and open it there, or whatever your approach is. We can discuss that in a second. But those are the exercises. So I encourage you to go one by one and try to solve them. So this is the medium level. So in medium level, you've got some questions and you've got some hints. In easy level, you've got already some code prepared. So if you are totally new to R and you just want to get the main idea, I think easy level is for you. But if you have at least a few weeks or few months of experience, try at least the medium one. And if you think that you don't like to start with medium and you like a little bit of challenge, start with the hard one. You can always switch. There is no way of deciding about the exercise. Okay, and I'm here, so I will walk around and I will help you as much as possible. And we still have around 45 minutes. So I will be around here and we can discuss some points that I mentioned, and I can also help you with the exercises. So good luck with the exercises, and during my second part, we'll focus more on reproducibility. But for now, let's focus on geocomputation with R.
So where are the slides? I don't find it in the Mattermost channel.
That's the website. So I don't know if it's going. Yeah.
Not where the town square. No. Yeah. So let's go to that. Plus. Okay. R like those are very good. So these are this one I can assume no. Yeah. This then called that's really about the ground is those exercises and so on. Is there more than one database? So we do our macro is really and how go on how to just maybe go along just so depending on the person I'll go to create the bonus. I have to this one I have to allocate product and geometry. Should be probably yeah, but copies and then you can yeah. And you can also that's something more different than that. Yeah, just yeah, so that's not the like, all of those like forms of usage supposed to find how to do that. Yeah, that's like that's on the easy note. Yeah, so I'll tell to everybody. So we'll still be around the second one.
So if you have any problems with installing packages like especially RGO boundaries, you can go to the Mattermost, and in the Mattermost, a week ago or so, I added prerequisites. So here you can find that to install this package, you need to use Remo's install GitHub VM GeoLab RGO boundaries, because this package is not on CRAN, so that's why you cannot just use install.packages. So that's how you can get it. I will repost that once more at the end of the as a new message, so maybe that will be easier for you to find. Yeah.
Yeah, so that's why I involved in implementation. I would have some example and then try to deal with what's the type of for us to let's go to the slide 16. I think this is I have a second. So I want to all right. So behind the first section based knowledge not stop that. I just mentioned yeah. Yeah. So yeah, it's good. So maybe no work. It's good that you like the work that's we started to yes, we come to the but also one thing that was yeah, so that's why we're electronic and then we just go to management. So yeah, so the two pounds for work this and for next year for the so yeah, all this we discover this you guys with everyone who is and what the source and there's even to operate some work but with the as but the unfounded lines after the 2 years of homeless Even one I was trying to make this okay. So you also have because you need to have the model. Let's just go to this. Okay, so they are that's needed for the party. So I think still and part of the main problem that we have right now is that we have very elevated R version. So low version is 15.6, which I think maybe like 2018, 17-ish. So now R is 4.2. So basically Microsoft part of the Microsoft is like 4.0. Still it's my usual recommendations to, if you can, to stay on the most recent version. So update this stuff every year or so, or half year. But if not, second recommendation is that only one version, but never like single version. I don't know. I did, I guess, so so you have you can do it? Yeah, so let's go to the RSI. So this type R stat. Well, in the case the part that was so now you can see it. Yeah, so download my. So that will be go to the cloud, so the first thing, and then go to the users. You wouldn't. You've got the description of how to update, but if you that then so that's how it should be. I think the same thing yesterday. So what's your introduction? Yeah, so I think you should get it to have more recent version. So yes, but also I think better now they will be just they have you can always focus on the sites that yeah, but you need to change one thing. Go back to the website. So I'm not going to go to try to okay, so it's okay. So it's on the text. Okay, so yeah, we can just run the code because this didn't go for a this one. Yeah, but it's here. It's as this will automatically detect the problem. Either pass you to type out the standards and now we behind here to the selection. So that's where it's not because we are still we can just yeah. This we don't go I think it's 4.4. But also it's all we are they can do the same part of the button, so we will use the which is to the double outside the two how do you want to get it takes some time to know the tempo of the speed. Yeah, you just get the speed line and provide the officially going to it. So that's the problem that like all the version. Now if you do this, you will get connected to the service of streaming version. So yeah, you can follow it since something that was going to see let's try the sound. Not really try to I think those are maybe just on the order the normal packages will be upgraded, so always will be upgraded. So hopefully we said it's 4.2. Hopefully if we're getting business this year like 2.6. Yeah. You will see in a second. For this update. Yeah. I'm looking for 100. Or yeah, 4.2. That's the next the right version. Now with that, you can Google and go find you need to I know it's not your version, but maybe there will be some features that we could use to do that and some other problems. That's the short for the previous version. Maybe in the sense of running the public, but how you can hold it for something. Commandments give such a good. What does it? Now we can help you with so far. I think you fix it. Yeah. You can also try to connect to the binary packages. Directly asking to see no. Use for that. So now everyone now we by default on the these source code. So you're now in source that you can compile it in copy this time. The other is important. Yes, yeah. Give me a second. For something, but it's not I'm doing that. This is for the browser. There is a problem. So that's the basic idea of this problem. And so they are the companies that are servers and primaries that are not so if you want to use that, you can install this. So you need to install the remote packet. So you need to enable, and then everything will install the will just like the so I click on the libraries. Okay. So I'll get all the libraries and everything. I hope so. Right again, I don't know how to make this. Yeah. So that's the decision. If you want to try to start, yeah, this session will be feature. Yeah. But if you go to the regular copy, you can have all the dependencies and plans stuff. Okay, let's try out. Thanks. Suggest this one was this is cool. Yeah. So that's okay, so let's go to the documentation. So there is where I will start. Just click on the somewhere on the name for the function, so like G or B. Yeah, somewhere in the middle of the function. On the function name, yeah. And just type it on. So you need to function function. So that's it. You don't need to cut out, you just need to have a function. That automatically shows the information. That's okay. So now we have country, and go lower. And with type, we have those options. Yes. Oh, there it is. Okay. So let's delete this empty space after 0. Or after 0. That's my give a second guess. Okay. So what I do usually in those cases, when I type and I'm thinking the right of not, then I try to stop copying and pasting and start again to type it up. Because so far, so far we can have those like you can click tab and now we get some help from that. So country, Germany. Now let's not restart the tab here. Just trying to that's now we know that this is okay. So now if we know that this is okay, we can then try to test with other types. So the time you try to use this test is so that's the answer. You've got SSC, GC. Oh, and this would be SSC. Sorry. No, that's the right good lesson because I wasn't able to, I was able to compare that 5 times. But now I just say that again. Your brain rewires. Yeah. Okay. Thanks a lot. Yeah. That's how. Yeah, it doesn't open. Look up. Why? That's why I just read the list. You just so after the read up the condition, that's what you just say. But you are doing less. Or you can solve people. That's one difference. No, because if you have a new version, so if your version is 4.0, and then you go from 4.0 to 4.1, your values are the same. But if you're going from 4.0 to 4.2, you need to restart all the things. Yeah, you need to restart all the things. So now you're using this you that's the soft because you need to do this if you want to enable the let's stop that. Let's restart the session. So I think it's basically like it's changes the computer to go to this binary instead of the software. Because this way you just install this package. And now we need to yeah, but I just wanted to use the answer because we are in science. Not only that. have them as a performance. They never make that. They never keep as a comparison. So no, it's like no card to other stuff. If you're looking at the sort of firework one was making this still like more right now that's the work to do it. It's hard to run this big again. So basically was to after the hardware. And now we're connecting to those to servers. Because it connects to different servers to because we are packaging all the different upload that also have a lot of syncing. Yeah, so I think that's why that's about my best. That's why it connects to different. Maybe this is just like some basically go through maybe better than half of our cases. But I think it's just like not even our cases, knows. Exactly. So like it's just refreshing not to be some not to change something and then it's like then it's strong and so it's like refreshing I don't know again I think it's yeah so okay. Yeah. I can no because now the maintenance basically then is that you don't need to do that. Basically, because there's a lot of problems when you work on some target menus or another events that everything breaks and the idea is that no, it should ever work. So you don't need to hide yourself or put yourself in your environment. Everything should work well together. That have this like a silence server because everything is tested against each other. It should work well. And not like in pattern then crash one thing against another. In our ideas, you can do everything which your R service and how do you get some of the local predictable journal? There's several ways. One I just type that. So that's what I usually start with. I get one for like 5 years. Also like I use the type like the journal rather than that. So that's one idea. And then you see yeah, results are looking for probably we want to go something for the whole country. So like those numbers couldn't go that. It's really fine. That's why it's also a packaging for CRS suggests. And it's just take your coordinate and then try to find some good prediction. That's a whole but I will do this one. That's it. Thanks. Yeah. So we have this legend because you still put them up behind. Because both layers so for the team up package, both layers are still there because some other users can have a raster here and program here and want to have two masks together. So this is raster layer is still there. So you don't want to select it, you need to disable this kind of you think that you would go about. By default it stays because you go back for after code. Yeah. So here we are saying H raster and bottom raster. So this code right, so that and then the second one.
Okay, there is no more everything about that. Okay.
There is something from the starting so I will just try to figure out.
No, it is different. here because we want to this before.
This is maintaining pretty steady.
Yeah,
all of this. My approach would be to start that session, just look at the beginning section, and then try to restart that from. And so, and that's what I think is the problem. My approach is also do the timer, restart that session, and then. But for now, it's just like. Active mode. Yeah. You can if you don't want to waste time, but now it's install the source for it. Okay. So maybe we're going to the same question. Yeah. Yeah, the whole mind of the code, the message very easy to picture. Okay. Because I also very easy to go from the yeah. No, it's we will take some time. The terra package is the longest. And if that one, but for now, so what I will do after that, decide on which and then just code them without running. Okay. I think yeah, to cover, try to write some like code and then you can just either to just I need something to change, not static for a year. No, this is serious error. This error is basically because terra, yeah, so this is serious error because terra connection to that, and this error basically it's good because it's trying to do the memory but the memory.
Now we are
yeah, that's at least fine. Yeah, because the first one is not really fun. I think I hope that thank you. We still have to stay much. But so it is don't fight about it. Check the authority and eliminate that one. Check it for on the six actually more the independent values. So there basically new blocks. We are not blocks in treatment when I for this new block or and after value no, syntax problem our subject so basically, and then we're yeah. So the current so let's go to smart town for and then we saw I didn't. This is secret that is that's forward let's completely take long
Right. Can I have your attention, please? I'm so happy that you look so focused. So hopefully your work on the exercises and you made some progress. Now we have some time for lunch. So hopefully you also want to go there. And after the lunch, I have another part of my lecture. The second part will focus slightly more about how to apply different reproducibility tools on spatial data problems. But we will also use the same examples and similar code that you been working right now. So hopefully I'll see all of you in about an hour. And if you have still any questions, you can just find me during the lunch, and I'm always happy to talk about R and about spatial analysis. So yeah, so have a nice break and see you in an hour.
Thank you.